With its length, this is not only the longest tunnel in the world, but also the deepest tunnel ever built at a depth of 2.5 kilometers. Why did this tunnel become a necessity for all of Europe? How did the engineering teams solve the problems of falling rocks inside the mountain, fast-flowing water, and the powerful air pressure that could even break the windows of passing trains? If we look carefully at the map of Europe, we can see a huge wall of mountains standing in the middle. For many years, this wall has created obstacles for trade and travel. This mountain wall is called the Alps. For centuries, people traveled over these mountains using long, zigzag routes. Sometimes snow and sometimes avalanches would block these paths without warning. Bridges were built on these mountains. Railway tracks were also extended, but climbing steep mountains by train was still very difficult and time-consuming. As time passed, another big problem appeared. To grow Europe's economy and transport more goods between countries, these zigzag routes were no longer enough. The factories of Northern Europe and the seaports of Southern Europe depended on each other. To solve this problem, engineers had only two options: either build even wider and more difficult roads over the mountains, or do something that had been considered impossible for centuries. They decided that instead of going over the mountains, they would go straight through them. They would build a tunnel inside the mountain, one that would be the longest and deepest tunnel in the world. But this mission, which sounds simple, was actually extremely dangerous. Deep underground, where the weight of the mountain could crush even steel walls like paper. Engineers knew they were not just fighting soil and rocks, but powerful natural forces that no one had ever challenged before. The construction of the Gotthard Base Tunnel was not ordinary. Its biggest enemy was extreme pressure, because the tunnel had to be dug under a mountain 2,500 meters high, meaning millions and billions of tons of weight would constantly press on its walls. To understand this pressure, engineers first tried digging a small tunnel, but the pressure of the mountain tried to close it again. And this was only the beginning. The second big challenge was extreme heat. Deep underground, temperatures can easily reach 50 degrees Celsius. In such heat, a human cannot work for more than 15 to 20 minutes. If the cooling system failed, the tunnel could turn into a living grave for workers. After pressure and heat, the most dangerous enemy was water pressure. This was not normal underground water. It was ancient water trapped for centuries under high pressure. If suddenly released, it could tear through concrete walls like a cannon blast. Because of these reasons, many famous engineers around the world clearly said this tunnel could never be built. They believed that machines would fail in such conditions, and workers would not survive. Also, the tunnel was being dug from both sides, 57 kilometers apart. If there was even a 1 millimeter mistake in alignment, both teams would miss each other inside the mountain, wasting billions of dollars. But for Switzerland, this was not just a project, it was a matter of survival. Every year, thousands of trucks crossed the Alps. Pollution was increasing and the roads had reached their limits. If this tunnel was not built, Europe's trade system could collapse. Switzerland decided that no matter the cost, this would become the greatest engineering achievement in the world. Now the question was not whether the tunnel would be built. The question was how to face these challenges. On September 27, 1992, the project was officially approved. This was no ordinary tunnel. Its scale was beyond human imagination. The total length was set to 57 kilometers. Such a long distance, and that too, 2.5 kilometers inside a mountain. In engineering, length is not just a number. It represents the level of difficulty. The longer the tunnel, the higher the risk of error. Engineers had to dig from both sides and meet exactly in the center. Even a 1 centimeter mistake would mean the tunnels would never connect. To solve this, laser navigation and GPS technology were used to calculate the exact drilling points. To make the impossible possible, the world's largest tunnel boring machines were built. These machines were so massive that their cutter heads were taller than a two-story house. One machine alone was 450 meters long, almost half a kilometer. But even with such advanced machines, progress was very slow. They could cut only a few meters of rock each day. These machines were not just tools. They were a test of patience for engineers lasting 17 years. At the same time, another battle was being fought, removing the excavated rock. During construction, about 30 million tons of debris were removed. This was so much that it could form an entire new mountain. Hundreds of trucks worked day and night just to remove this material. Every day, thousands of workers went deep underground, where there was no sense of day or night. No phone signals, no fresh air, only the noise of machines, the smell of earth, and an underground world where up to 2,600 workers lived and worked. Soon, engineers realized that the real enemy was not the tunnel's length. As they went deeper, they faced a challenge they expected, but were not fully prepared for. At 2 kilometers below ground, rocks release intense heat. As machines moved forward, temperatures kept rising, 30, then 40, and finally 50 degrees Celsius. The site became more like an oven than a construction area. In the early days, workers would be drenched in sweat within minutes. Operators were allowed to work only 2 to 3 hour shifts to avoid heat stroke. To solve this, cooling pipes were installed, carrying cold water from outside into the tunnel. This became the first construction site where the environment for workers was created before construction continued. But heat was only the beginning. The real danger was the immense pressure of the mountain. Cracks and rocks, sudden collapses, these became daily events. To handle this, workers sprayed concrete on weak areas. In some places, precast concrete slabs were installed. In others, steel rings were used to create an artificial support structure. This helped stabilize weak rocks. But after solving the problem of falling rocks, engineers faced another threat: water. During drilling, at one point, a powerful flow of water burst out from inside the mountain. Mountains are not made of one type of rock. Some areas are very hard, while others are soft. Water is stored inside cracks under extreme pressure, up to 2,900 pounds per square inch. This is like placing the weight of a car on a single square inch. The only solution was to freeze the water. Before drilling, small pipes were inserted and freezing liquid was passed through them. After several weeks, the water turned solid. Now, when machines drilled through, the frozen water behaved like normal rock. After drilling, concrete lining was added and the freezing system was turned off. Engineers also created collection channels between the concrete lining and the mountain so water could flow out safely without building pressure. After overcoming this final obstacle, only one moment remained. The moment when both sides of the tunnel would meet. On October 15, 2010, the world watched Switzerland. Deep inside the mountain, both teams were separated by just a thin wall. The question was, would 17 years of effort succeed or turn into a 57-kilometer grave? Suddenly, the cutter head broke through the final wall. It was a historic moment for all of Europe. When measurements were checked, the difference between the two tunnels was only half an inch. This accuracy was like threading a needle from 50 kilometers away. You might think rocks and water were the biggest enemies, but the real enemy was air. When high-speed trains enter the tunnel, air has nowhere to escape. This creates a shock wave strong enough to shatter windows. To solve this, engineers built not one, but 2 tunnels. They also added connecting passages and ventilation shafts at regular intervals. These allow air pressure to escape safely. If this had not been planned, 17 years of work could have been destroyed. The idea of this tunnel was first proposed in 1940, but construction only began in 1993 due to engineering challenges. It took 17 years, 2,600 workers, and $12.5 billion to complete. The mountain above is as tall as 3 Burj Khalifas stacked together. To ensure perfect alignment, GPS, gyroscopes, and laser systems were used. The tunnel was even designed considering the curvature of the Earth. The excavated material could have built 5 Great Pyramids. Instead, it was used to create artificial islands in Lake Lucerne. The 450-meter-long boring machines used as much electricity as 20,000 homes. Finally, we remember the 9 workers who lost their lives during construction. A memorial stands at the entrance of the tunnel to honor them and remind the world of the true cost of this engineering marvel. We will meet again in another amazing story.